Hello. Alright. What happened? Let's check your remind message, okay? Alright, I answered your message, Miles. Alright, so, as you know, next week, this is like technically next week's class, and after this week will be in June. And say goodbye to our senior members. Senior member meaning old people. I'm sorry, the last year people, right? This is technically their last week, right? Miles. And I think you're, who else is 12th grader? I think you're the only one, no? Oh, yeah, I think you're the only senior in our class. All right. So congratulations, Miles. You made it. Anyway, so we'll get started, I guess. Okay. So today we're going to talk about sigma notation. All right, sigma notation. That is this symbol right here. How many of you have seen this before? Do you remember what that is? What the meaning of it is? Have you seen it before? This is named sigma, Greek letter. Right? What does it mean? You guys have an idea? Like if you, yeah. So even when you're working with Excel, if you go to, I don't know how many of you are familiar with Excel or like sheets, that kind of thing. If you want to add something, there's an icon that looks exactly like this, okay? So like if you want to add up a column or something like that, then you can use equal sum. The sum symbol looks like that in the old computer, at least. I think now some of them just give you an option that says sum, okay? But anyway. Regardless, this is sum. How am I summing this? I'm summing this expression. This is the expression I'm summing. Okay, this means sum. Sum means adding, all right? What am I adding? I'm adding everything of this form. But you have a k here, right? What would the k be? Here it says k equals 1. But not just 1. It starts from 1 and it counts up. So 1, 2, all the way to 3. So in this case, it would be k squared plus 1, right? So when k is 1, this will be what? 1 squared plus 1, right? That's the first one. Plus, when k is 2, which is 2 squared plus 1, right? I'm changing the k value. Plus 3 squared plus 1, like that. All right, and you add them up. Does that make sense? So I'm summing the k squared plus 1. What is k? K is from 1 to 3 in that order, okay? So that's what it means. So add them up. Add. What is this? Do the math. This is 2 plus 5 plus 10. So 17. Does that make sense? So that would be what that means. Okay? All right. Number 2. What would that be then? Well, can you try? What would the answer of number 2 be? What would the answer be? That so you put in so the answer turns out to be 30. Okay, so same thing. I want to add 7k minus 3, but this time my k wants to start from 0 and then go 1, 2, 0, 1, 2, 3. Okay, so you add them up. All right. Here we go. Questions about this so far? Pretty good, right? So can you try 3 and 4 as well? Well, try 3. We'll look at 4 together, okay? Try 3 first. All right, type the answer in. What do we have? So, I got -4. Does that sound right? Starting from 4, right? So, right, -1 to the 4th power, 2 times 4 minus 5, plus -1 to the 5th power, 2 times 5 minus 5, like that, plus 1 to 6, 2 times 6 minus 5, plus negative 1 to the 7th power, 2 times 7 minus 5, okay? And it turns out to be negative 4. Do we get the same answer? Does that look right? Do we understand how you use sigma notation now? The meaning of it? So the notation goes like sigma, right? You start from start, right, to end, right? This is your index. We call this the index. Okay, K is the index. And then whatever here is the expression that you're adding. Okay, this is the expression. All right. So, shall we look at this? So, if you are pulling this out, it will get 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus all the way to 1 over a big number, right? But you don't want to put infinity here. Okay, I'll put n and you keep going, right? Keeps going. You don't want to put infinity here because infinity is not a number. So I just keep over n, whatever n is, and then it keeps going. Okay? Now, question for you. Do you think, okay, we're not going to prove this, but question, does this sum converge? Okay? What does converge mean again? Well, converge means that the sum of this will equal to a number eventually. Like the whole thing will equal to a number. For example, remember 1 plus 1/2 plus 1/4 plus 1/8 plus all the way to infinity. This is an infinite geometric series, right? And then when we add these up, we say that this converges because the ratio is less than 1, right? R is 1/2. Right? So when we do infinite geometric sum, we say it converges because r is less than 1 and the sum is exactly equal to t1 over 1 minus r, right? Which is first term over 1 minus 1/2, which is 2, right? This is called a convergent series, right? I converge to 2, meaning this whole thing will add up to 2, okay? But does this, do you think, all right, type it in the chat, do you think this series, 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, adding these up, does this converge? Okay, do you think this converge at all? Okay. And then why or why not? Okay, give me something. All right, answer the question and then tell me yes or no. Do you think it converges to a number, the sum, when you add them all up? Type in the chat. I mean, you can try it with your calculator too. Does this converge? All right, well, let's try it in the calculator if you're not sure. All right, so I'm gonna start adding, okay? 1 over 1, right? 1 over 1, right? Plus 1 over 2, plus 1 over 3, plus 1 over 4, plus, we'll start with this, okay? It's 2.08. Sounds like it doesn't go that big, right? So let's repeat. Okay, let's keep going. 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8 plus 1 over 9. All right, 500. Oh, doesn't that feel like it's going bigger? Oh, let's keep going. Plus, oh, okay. Plus 1 over 10, right? Plus 1 over 11 plus 1 over 12 plus 1 over 13 plus 1 over 14. Whoa! Doesn't it give you a feeling that it just keeps going up? Right? It started with 2, and then 2.8, and then 3.25. So, in our mind, we think it converges, right? We think it converges. But the reality is, it doesn't. No. Alright, no. Okay. Isn't that interesting? I thought that was pretty interesting. So that means even though I'm adding smaller and smaller things, does not mean that the whole sum will go to a number. Okay? Some of them do, some of them don't. This one does, this one doesn't. This is called a harmonic series. Harmonic. It just has a name because it's special. 1 over 1, 1 over 2, 1 over 3, 1 over 4. This is one of the most famous divergent series that we have. In the future calculus years, you'll learn about this more. But just keep in mind for now that not every series that goes smaller will converge. Some of them don't. This one doesn't. This one does. Okay? Alright. So, how are we doing with sigma notation? Can I get a quick comfort level real quick? 1 to 10? Obviously minus the, well, actually just in general. Not bad, right? You know how to use it. Alright, so, seems acceptable, right? Alright, so, since that is the case, then let's look at the actual adding them together for many terms, okay? Hey, what does this mean? What is this? So, I need to add an expression from k equals 1 to k equals 100. But you realize there's no k. Well, there's no k, then you don't plug in k. But each one will then be the first, when k is 1 is 1, right? What about k equals 2? When k is 2, still 1. When k is 3, still 1. And you keep doing this until k is 100, which is still 1. Right? So what do I have? I have 100 terms of 1. So what's the sum? Isn't that 1 plus itself 100 times? So that's going to be 100. Okay? That's the idea. Alright, if it doesn't have a k, then that's just it. Okay? So, if that's the case, then what is k equals 1 to n of 1? Isn't that just n ones? So that should equal to n times 1, which is n. Okay? Like that. So if this is 2, then it's n times 2. If it's 3, then it's n times 3. Okay? Does that make sense? Okay? Now, next thing. So, what if I have n from 1 to 100, I from 1 to 100 of I. So I just switched notation, variables. Index variable is now I, that's fine. Still, i's changed from 1 to 100. Isn't that 1 plus 2 plus 3 plus 4 plus all the way to 100? Do you remember how to add 1 to 100? Isn't that a arithmetic or trapezoidal series, right? You just do first term plus last term times number of terms, which is 100, over 2, right? We took this previously. In this case, is 101. 101 times 100 over 2, so 50, 50. All right. Well, similarly, what if I start at a random number, not 100? Isn't that just 1 plus 2 plus 3 all the way to n? How do I add this? Same thing, arithmetic series. N plus 1 times number of terms n over 2. Remember this formula we had before? So stick with this. When I have to add sigma of I or k from 1 to n, this would be my formula. Okay, keep that in mind. How are we doing? All right. So, I want to add one more thing. So far we have, say, k equals 1 of 1, or 2, or 3, you just multiply it, right? You have k or I, then it would just be this. Okay? This represents the sum, all right, the whole thing. This is the expression, okay? All right, so now we have that. Let's look at this. From k equals 1 to n of k squared, okay? So there are many ways to prove what this ends up being. So this is 1 plus 2, 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus all the way to n squared, okay? Like this. Now, there are ways to prove this, what this will equal to, but I'll save you some brain power. If you're interested, there are two main ways to prove this. One is called math induction. This is the one I like to use the most. Number two is called binomial expansion. What is binomial expansion? It has to do with k minus 1 to the cube. That kind of thing, like when you cube it. But regardless, these two things are currently something that we don't focus on at this moment. Induction was going to be part of the curriculum if we didn't have this lockdown. But regardless, the answer to this sum is going to be n plus 1 to n, I think it's minus 1, to n minus 1, if I'm not mistaken, or 2n plus 1. Man, 2n plus 1, yeah, over 6, okay? We sometimes use this, k squared, okay? So, let us use some ways to do this. So for example, oops, let me put it over here. If I want to find sigma, okay, let's just say k equals 1 to 50, okay, of 2k squared plus 5k, okay? Normally, this is a very hard problem, right? Why? Because you have to keep putting 1 in, 2, 3, 4, and do 50 terms, right? And you don't know how to do this quickly. So we can use the fact that, okay, you're adding things, right? Adding is commutative and associative, which means that you can add all the things that have this expression first, and then add all the things that have this expression first, then in the end add them together. What do I mean? I can split this sigma. Okay? I can split it into 2 sigmas. Right? Why can I do that? Because adding is associative and commutative, right? You can do things in different order, shouldn't matter, right? We're adding things. Okay? Okay, well, think about this. Every time I plug in 1, I get 2 times 1 squared, 2 times 2 squared, 2 times 3 squared. That means everything has a 2 in it. I can factor this 2 out. So I can pull this 2 and 5 forward. Okay? That'll become 2 sigma k from 1 to 50 of k squared plus 5 sigma k from 1 to 50 of k. Okay? And then now, hey, I'm familiar with these two expressions. Why? Because we have formulas for them, right? Here, see? Formulas for, let me rewrite them in the bottom so you remember what they look like. So sigma k from 1 to n of k is n plus 1 over 2. Sigma k from 1 to n of k squared is n plus 1 to n plus 1 over 6. Okay, so we're going to use the fact that we know this, and I'm going to apply the formula for n is 50, because that's what I'm starting, right? So, that's what I'm ending. So 2 times, it's going to follow this formula, right? This one, k squared, right? K squared. So 6, 50, 50 plus 1, 2 times 50 plus 1, okay? Plus 5 times 50, 50 plus 1 over 2. All right, and you calculate this, okay? I'll use a calculator here. 2 times 50 times 51 times 2 times 50, so 101, divided by 6. So this first part is 850, plus the second part is going to be 5 times 25 times 51, which is 6375, which is 92225. Okay. So that is, yeah, I'm pulling it down, I'm pulling it out. You got it, okay? Okay, so this is one way we can use these two formulas. These two formulas you would use sometimes. Okay, whenever you have k squared in your expression, you can break it down like how I do. Okay, I have one problem like this on the homework for you to practice. Okay. All right. Can we flip over? All right, so the next thing is where you need to write the following in sigma notation and then find the sum. Can we do that? Can we find the sum? All right. You want to write it in sigma notation. I'll do 1, and then you can do the right side. Okay, sigma. So first of all, there are 100 terms, so I know it's going to be k from 1 to 100. Okay. All right. What kind of series is this? What kind of series? Look at this. Put it in the chat. What kind of series is this? What kind of series is this? arithmetic sequence, right? Oh, a series, right? So you're adding an arithmetic sequence, which means each one of them should be represented by arithmetic. So to represent it, I would use the arithmetic formula, which is a1 plus m minus 1d. Okay, I'm gonna use that. A1, first one is 2 plus, I'm using k, right? Because my index is in k. K minus 1. What is the difference? Difference is plus 6, right? So we put 6 here. So technically you can do it like this. Oops, why is it blurry? Come back, don't be blurry. What the? Interesting. Alright, I'll pull this a little bit back. Alright, so I'm going to use this expression. I can simplify a little bit because I'm going to calculate this, right? So it will end up being 2, so 6k minus 6 plus 2, so minus 4. Right, like that. 6k minus 4. Does that look right? And I'm going 100 terms, right? So, hey. Now I'm going to use the same way I was doing earlier. I'm going to break this. Okay, I'm going to break this into 6 sigma k1 to 100k minus 4 times sigma k1 1. Okay? So then, once I break this down, remember this formula 6. This is k formula, right? Remember the k formula? Flip to the previous page if you forget. But this is 2 n plus 1, right? So it'll be 100, 100 plus 1. Okay? Minus 4 times, remember what this is? This is 100 ones add together, right? Because there's no k here. So 100 ones add together is 100. Calculate this. Here we go. Calculator says 29,900. Okay, 29,900. Try the right side. While you're at it, type if you're here, so I can give you attendance. Type an answer if you got it. Let's see. So 2 plus 8 to all the way to n, right? So when we do this, all right, let's look. So everything else here is the same. So you're following this, so it's the same exact thing here, right? And the next thing would be, right, you still get this. To the n power, not n power, to the n term, right? And here is still the same, so you'll get minus 4. Oops. What the heck is happening? Okay. You get this, right? Minus 4 times sigma k from 1 to n. Okay. So you keep calculating. Sally, I think you're right. And you keep going. So this will become 6 over 2n, n plus 1, minus 4 times n, right? Because this is n k's, right? So it will be n. This will be 3, so it'll be 3n squared plus 3n minus 4n, which ends up being 3n squared minus n. Okay? The rest is algebra once you figure out the rest. Okay? All right. All right, try number 8. What will number 8 look like? Well, first of all, what is number 8? Isn't number 8, when you write it, it would be what? Equals, this is what kind of series is this? 1 plus 3 plus 9 plus 27 plus 81, etc. What is this? What do we call this? Isn't this geometric? So let's just write it. How many terms is this? 1, 2, 3, 4, 5, right? So we'll do 5. So geometric, we're gonna do, so geometric is gn equals g1 r to the n minus 1, right? That was my geometric sequence formula. And since we're adding each one, so it'll be 1 times r is 3 to the n minus 1, okay? Or k minus 1, k minus 1. All right, to add this up, you basically can just add it up because it's so few terms. If you just add them, answer is 121. Okay. Or if you can use the formula, it would be the formula, right? Sn is g1 1 minus r to the n over 1 minus r. In this case, it would be g1 is first term is 1 minus 3 to the n power over 1 minus 3. So this would be 243. So negative 2 over negative 2, which is also positive 121. Okay. Regardless of how you do it, you should get the same answer. Okay. All right. 9. Same thing, right? What is this? Geometric. R is 1/2, right? This is infinite, right? Infinite. So we know infinite geometric series. In this case, it converges because R is equal to half. But we need to write in sigma notation as requested. So k from 1. Since we have no bound, we can put infinity here. Okay, this is called infinite geometric series, or infinite series in general. We can put k equals 1 to infinity. Then the expression, right? 48 is your first term. 1/2 to the n minus 1, or k minus 1. K minus 1. Okay, so that would be my expression. Okay, that would work. And then, if you want to actually calculate this, you can use the formula that we had for infinite geometric series, T1 over 1 minus R, from this week earlier, right? So it would be 48 over 1 minus R, which is 1/2, which ended up being 96. Okay. All right, so we learned for sigma k squared, and then we combine it with the geometric series we learned before, which is independent from the stuff we've done before, because this is a geometric sum. Geometric sum, we have a formula for. We don't have to worry about k squared, that stuff. Okay? One last one. Write in sigma notation, last one. 3 plus 7 plus 11 plus all the way to 715. So let's see what we need for sigma. Okay, so sigma k, we start from 1, okay? What kind of series is this? What is this? 3, 7, 11. This is plus 4 each time, right? You see that? Plus 4 each time. Since that's plus 4 each time, then that's your difference. Difference is 4. First term is 3, so it should be 3 plus n minus 1. Difference is 4, right? Now, what's missing? Well, I don't know what this part is. Now, to know that part, I know my last term is 715, right? So in other words, you just need to know when 715 is equal to that. Okay? Because that would determine what my n value needs to start. You should switch this to k as well because your index is in k, okay? Alright, so here we go. Then you would set them equal. So 3 plus n minus 1 times 4 equals 715. You solve, right? So n minus 1 times 4 is equal to 712 divided by 4. So we get n minus 1 is 120. No. 178? Yeah, 178. So n is 179. Okay, so that's what you put here. They didn't ask us to calculate, so we can just leave it. Or actually, let's simplify this a little bit. From 1 to 179 of 4k minus 4 plus 3, so minus 1. Okay, that's all. So same thing as what we've done before, we just introduce a new notation called sigma notation. And that's it. Hi, Matthew. All right. Can I get a comfort level in general from 1 to 10 for this lesson? One to 10. 8, 7, 7, 8.5. 7, 8, 8. Okay. So, your homework, obviously is due next Sunday, would be the review. Okay. I know originally I said that the test is gonna be next week, but it's not gonna be next week. Okay. It's not gonna be next week. We'll probably leave it until June. So stay tuned. Okay. Test is not gonna be next week. All right. Because technically this is next week, right? Who's Kanur? Huh. Kanur, do you not get this lesson? Who are you? So your homework is over here. All right. I also printed the same thing and put it on Google Classroom so you can follow it. Basically, the review of the whole thing with Sequences series. Ever since we started chapter, I think this is day 13, which is, All right, so June will be the next time we see each other. All right. Any other questions before we end? Pretty good? Well, if that's the case, then have a great long weekend, 3-day weekend. Although I don't know, every week is a 3-day weekend for you guys, so I don't know what difference does it make, except that you have 2 classes this week. Bye. Bye.